Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand VRF. VRF stands for Virtual Routing and Forwarding. Very easy topic. By the way, we are using this technology with MPLS or you can say with BGP in MP-BGP, multi-protocol BGP. But don't worry, if you don't know the MPLS, then also you can understand the VRF. Okay, so guys, without wasting our time, let's begin the topic. Let's understand the VRF. First of all, what is VRF? So VRF is a technology which is used to create multiple routing instances on a router. By default, as you know, let's say a router have two interfaces. So both are member of a single routing table. We cannot configure like same network on both interface. If you will configure IP address from same network on the multiple interface of a router, it will give you error, that overlapping error, right? So VRF is a technology which is used to divide a router virtually. See, if you are thinking that why I will divide the router virtually, so you will understand the scenario, in which scenario you need to divide the router virtually, or you need to create multiple routing table on a single router. Okay, like if I will talk about the concept of VLAN. So what is VLAN? VLAN is used to divide broadcast domain. So with the help of VLAN, we can create multiple broadcast domain on a single switch. Like that. Okay, let's say I have one router here, R1, and this router have two interface, this one and this one. Let's say this is F0/0 and this is F0/1. By default, we cannot configure IP address from same network on both interface of this router. Let's say my requirement is I need to configure same IP address on both interface of router. Right, this is VRF, by the way. In VRF, you will see you need to configure maybe same IP address on multiple interface of router. So by default, you cannot configure, because by default both interface F0/0 as well as 0/1, these both interface is member of global routing table. Global routing table. As you know, router maintain routing table. So when we are configuring IP address on the interface of router, what router is doing? Router will make one entry in their global routing table. That routing table is global routing table. Like here, let's say I am configuring one IP address 10.1.1.1. So once I will assign this IP address on this interface, this router will put network ID of this IP address, that will be 10.1.1.0. This network is directly connected on my interface fast Ethernet 0/0. Like this router is going to build routing table, going to maintain routing table. After that, when I will configure IP address over here, if I will try to configure same IP address 10.1.1.1, then it will give me the error. And let's say here I am configuring IP 20.1.1.1. So again it will make one entry in their table that 20.1.1.0 network is directly connected on my fast Ethernet 0/1. Right? Like this router maintain routing table, you already know this. Okay, in VRF, my requirement is I need to configure same IP address, this IP address as well as this same IP address on both interface, on this interface also. Then router cannot put two network on multiple interface in the global routing table. So router need to maintain what? Two different routing table this time. So exactly in VRF, or what is VRF? VRF is used to break the routing table of router. Like here, router should maintain two different routing table, one for this interface and one for this interface. Exactly we will do same thing in VRF. In VRF, we will assign this interface to a particular VRF. Let's say this interface is a member of VRF1 and this interface is member of VRF2. So now router is going to maintain two number of routing table, one for VRF1 and one for VRF2. If you are thinking that why I need to configure this interface is in VRF, so just wait for 5 minutes, guys. I am going to make you understand this only in this video, right? After that, on my laptop screen I will show you the configuration. Okay, so till now if it is clear to you that what is VRF, then please hit on like button guys, and let me know in the comment if you have any question till now that what is VRF. So VRF is a technology which is used to divide physical router virtually like VLAN, or you can say VRF is a technology which is used to create multiple routing table on a single router. Okay, now try to understand where or the scenario when I need to configure same IP address on the multiple interface. Guys, like you know, why we come up with private IP and public IP? Because we have shortage of IPv4 address. That's why we come up with private and public, so that multiple customer can use same private IP address. Let's say there are two customer 1 C1 and C2 CB, customer A, customer B. Both customer are using same network, let's say 10.1.1.0, and we are service provider. What is the function of service provider, guys? There is some difference between service provider SP and ISP. ISP is responsible to provide you internet, and SP is responsible to provide you connectivity between two points. So let's say these two customers have connectivity through my ISP, through my service, through my network. We are service provider, let's say. Okay, so how I will differentiate if both are using same network? Let's say customer A is using network 10.1.1.0 and customer B is also using same network 10.1.1.0. Both are using private network, and as you know, multiple customer can use same private network. So these two customers are going to communicate with each other through my network. So over my network, how I will differentiate the network of customer A and customer B? So here is the requirement of dividing routing table of a router virtually. Let me make you familiar with one example, guys. Here I am going to design one topology. Let's say there are some customer, there are one customer Dell or IBM. This is a small organization of IBM company. This is switch, and here are the user of IBM. Getting my point? This is IBM. Okay, like this we have one more a small organization. Let's say this is switch of Dell, switch of Dell, and there are some user connected with this organization. Okay, this is nothing but your Dell. Okay, both organizations have their branch offices in different location. Let's say this is the side 1 of IBM side 1. This is Dell side 1, and Dell's or IBM side 2 is located in different location. Let's say here is again switch, and here are some user. This is, let's say, IBM side 2, and here is the side 2 of Dell also. This is side 2, Dell side 2. Okay, now they need to connect their branches, right? And let's say IBM is using network 10.1.1.0/24 network in this side, and in this side they are using, let's say, 10.1.2.0/24. In the same way, Dell is also using same network. Here Dell is also using 10.1.1.0/24 network, and here they are using 10.1.2.0/24 network. Okay, and we are service provider. So here is my network, let's say R1 and R2. This is service provider. Let me. There will be some more router guys between router 1 and router 2. I will show you while configuration. You know there will be some more routers. This is nothing but the PE router, provider edge router. This is nothing but the PE router, provider edge router, and between provider edge there will be lots of provider router. Okay, so we are not discussing about that router for now. Okay, now IBM need to connect their both branch side 1 and side 2 together through service provider. So IBM also need one router. So let's say this is router of IBM, and through router they have connected their network like this. Okay, and Dell also need to connect. Okay, first of all let me connect side 2 of IBM. So here also we will have one router, and through that router both network of IBM side is connected. Okay, in the same way Dell will have one router over here to connect their both branch together, and they will have one router here. See, now in this provider network, provider need to forward traffic of IBM also, and provider need to forward traffic of Dell also through the same router, on the same router. So how you will differentiate the network of IBM and Dell on R1? Getting my point? Here on R1 you can, by default you cannot differentiate the network, right? Let's say they are using any routing protocol for the connectivity. IBM is using, let's say, EIGRP routing protocol, EIGRP, and Dell is, let's say, also using EIGRP or any other routing protocol, OSPF, for the connectivity. Getting my point? So this router will learn this network, right, through EIGRP, and this network through OSPF. But as you know, it cannot install both network in their global routing table. It will install which network in their routing table? Through EIGRP or through OSPF. So which routing protocol have least AD value, right? So if I will talk about the AD value of EIGRP, AD value of EIGRP is 90, AD value of OSPF is 110. So router 1 will install IBM path, IBM route only. Getting my point? In the same way, router 2 will also install this network 10.1.1.10.1.2.0 via this router. Let's say this is R1, sorry, R3, this is R4, this is R5, and this is R6. Getting my point? So router 1 will install this network 10.1.1.0/24 via router number 3. Router 2 will install this network 10.1.2.0/24 via router number 5. That means Dell cannot communicate now, right? If this user want to communicate with this user, they can communicate, but Dell user cannot communicate with each other. So as I am service provider, in this service provider network, we will use this technology called VRF. Why we will use VRF? We will put this interface in different VRF. This interface is, let's say, VRF of IBM, and this interface is VRF of Dell. So now router 1 is going to maintain two routing table, two separate routing table. In both routing table, there will be this prefix 10.1.1.0, 10.1.1.0. Whenever it will receive any prefix, any traffic on this link. So this link is a member of which VRF? Dell VRF. So it will forward traffic to Dell VRF. Now here again problem is we have a link on this link. How we will differentiate the traffic? So for now just I am going to connect one more link guys between router 1 and router 2. After that I will make you understand how single link will work. Okay, for now let's say I have assigned this interface is in IBM VRF and this interface is in Dell VRF. This interface is in IBM VRF and this interface is in IBM VRF, and this interface is in Dell VRF. Del VRF. Okay, so when this user now 10.1.1.1, let's say IP address of this user is 10.1.1.1, want to communicate with 10.1.2.1, it will forward traffic to their customer edge router. This is CE router, this is also CE router, this is CE router, and this is CE router. Okay, provider edge, customer edge. Now when this user want to communicate with any other user, any user of side 2, so it will forward traffic to customer edge router. Customer edge router will forward traffic to provider edge. Provider edge will have two routing tables. See, one routing table will have the one routing table. Inside the one routing table there will be prefix of IBM. Let me make the routing table a little bit bigger. Here is the routing table of R1, and it will have two routing table as I told you. This is the routing table of IBM VRF, and this is the routing table of Dell VRF. Okay, inside this routing table there will be some network. Let's say here I am using network 12.1.1.0, here I am using network 23.1.1.0, let's say any network. Okay, so inside the IBM routing table, okay, there will be two network. One is this one 12 network, 12.1.1.0/24 is connected on this link. Let's say this is serial 2/0, this is serial 2/1. Okay, so serial 2/0. Okay, right. After that there will be one more network. This network, the network which is running between customer edge and provider edge. Let's say between customer edge and provider edge I am using 1.1.1.0/24 network. Here also 1.1.1.0/24 network. Here I am using again 1.1.1.0/24 network. Here I am using 1.1.1.0/24 network. Getting my point? So I can use same network, right, on this interface, because now both interface belongs to different VRF. So there will be information of this network also. 1.1.1.0/24 is connected on 0/0 interface. After that through EIGRP it will learn this network 10.1.1.0/24 network, right? And exit interface for this network will be 0/0, and as you know 0/0 is a member of IBM VRF. Okay, after that if I will talk about the routing table of Dell VRF, so here also there will be 23.1.1.0/24 network. After that 1.1.1.0/24 network, and then this network 10.1.1.0/24 network. This is the routing table. After that, as you know, here we will we will configure BGP, and for now let's say we are using EIGRP only. So through EIGRP router 1 will learn this network as well, right? So there will be this network also 10.1.2.0/24, and this router will also learn this network. So this network will be learned by router 1 on this interface, and this interface is member of Dell VRF, so it will install this network in this routing table 10.1.2.0/24. Now you can see the routing table of both VRF look like similar, but whenever it will receive traffic over here on this interface, it will check which routing table, it will check this routing table. Whenever it will receive traffic on this interface, it will check this routing table. In the same way, router 2 is also maintaining two routing table, one for Dell VRF and one for IBM VRF. Whenever it will receive traffic on this interface, it will check routing table of IBM VRF. Whenever it will receive traffic on this interface, it will check routing table of Dell VRF. So now hope it is clear to you that in which scenario I need to configure same IP address on multiple interface of router, and why we need to divide the router virtually. Here if I will not divide the router virtually, then we cannot connect the side 1 of IBM and side 1 of Dell, because both are using same private network, and as you know multiple customer can use same network. Okay, or you can consider that this is customer 1, this is customer 2 also. Now problem is here, you are thinking that if let's say I need to connect 100 number of branches, then I need to connect 100 number of cable between router 1 and router 2. So no guys, if I have 100 number of branches or 500 branches or 5000 branches, I need to connect only one link between router 1 and router 2. By the way, if I will talk about the provider network, let me remove this, let me erase this diagram here. If I will talk about the provider edge router, provider network, so provider network will look like this. Let's say this is the provider network. Router, there will be lots of router here, and all routers are connected with each other like this. This is the provider network. Getting my point? And now we are talking about this router. This is PE router, provider edge router, and this is PE router, other PE router. I was connecting sides of IBM and Dell through this router and this router. So these two are provider edge router. We are not going to discuss the configuration in this network. Here we will run MPLS. But let's say this is my provider 1 and this is provider edge, another provider edge. Okay guys, on a single link, see, on a single link, if you want to differentiate the traffic, let me design one more topology here. Let's say I have one switch here, and through this switch I have two computers, PC1 and let's say PC2. This user is in VLAN 10, and this user is in VLAN 20, and here I have one router. Just I am giving you one example. Okay, one router. How you will make communication possible between different VLAN? Here we need to configure what? Inter-VLAN routing. To configure inter-VLAN routing, here I need to create sub-interface. I will create two number of sub-interface. One, let's say this is 0/0. So my sub-interface will be 0/0.10 for VLAN 10, and we will assign the IP address on this particular interface. After that we will create one more sub-interface 0/0.20 for VLAN 20, and we will configure the IP address. That means what we are doing here, we are dividing one single interface into multiple interface, right? These are sub interface. Why? To configure multiple IP address on a single port, because physical port is single. We are dividing physical port virtually. So like that also, here we can forward traffic of multiple networks on a same link by creating SVI interface. Let's say here this is VRF A, this is VRF B, this is VRF A, this is VRF B. I need to connect customer A to customer A network, other side of customer A, and customer B to customer B, right? Let's say customer A have IP 10.1.1.0, here also 10.1.1.0, here 10.1.2.0, here 10.1.3.0. So what I can do here, I can divide this physical interface into virtual interface. Let's say this is 0/0, this is also 0/0. I can say 0/0.10, and I can define a particular VLAN, let's say VLAN 10, and I can assign the IP address 12.1.1.1, right? After that 0/0.20 for VLAN we can define 20, and I can assign IP address 23.1.1.2, and this virtual interface, VLAN interface, will be member of which VRF? VRF A, and this interface will be the member of VRF B. Like this also we can forward traffic of VRF A and VRF B through the same link. Yes or no? I will configure this port as VRF A and this port as VRF B. In the same way I will do configuration on router number 2 also. But okay, this is also a way to forward traffic of VRF A and VRF B through single link. But guys, in real time, you will have only one link, and on this link, to separate the traffic, we have one concept of RD value. RD. In VRF, prefixes will have RD value to differentiate the network, to differentiate the network. So let's say this is the network. Here I can add one RD value, let's say 1:1. 1:1, and complete IP will become 1:1. After that 10.1.1.0. This is the complete network. Guys, this network is called VPN v4 network. This is not 32 bits network. This is 96 bit prefix, because RD is 64 bits value. So 64 bits is the RD value, and after that size of your IP address is 32. So total size will become what? 96. So this route will have length 96, and 96, if this type of prefix whose length is 96 is called VPN v4 prefix. And to forward VPN v4 prefixes, normally in service provider network we are running routing protocol what? BGP. But BGP routing protocol, normal BGP is used to share 32 bits prefix. 32 bits prefix. Normal BGP cannot carry these prefix, 96 bits prefix. So here we have one more types of BGP, that is MP-BGP. Maybe you know or you don't know. MP-BGP. So between router 1 and router 2, in the service provider network, we will configure MP-BGP. And MP-BGP configuration and RD concept, right? And the concept of a single link, I will make you understand in practical. So this is just a theory part. Through this video, just I want to make you explain, guys, what is the need of VRF, why we are using VRF, and what exactly VRF is. Okay, what exactly VRF is, why we need to divide router virtually. Okay, that's all. There is no any other reason of making this video, because I am going to make you understand everything through the practical video, through the configuration. While configuration, I will show you how you will configure MP-BGP over here, how you will set RD value, how you will import the prefixes, how you will export the prefixes, everything. Okay, so now guys, that's all for today. If you have learned something from this video, please hit on like button, guys. If you have not subscribed this channel, please subscribe this channel, because I am making this type of video every day. So if this type of video is helpful for you, then please subscribe the channel. And whenever you are learning something, you are getting something, please let me know through comment, because your comment is very important. When I am checking the comment, when you guys are getting the point, getting the concept, then it motivating me to make more videos. Okay, so that's all for today. Let's meet in next video. Till then, stay safe, guys. Bye bye.